Section 1-4 is entitled Solving Absolute Value Equations. Recall that the absolute value of a number is its distance from 0 on the number line. So for example, the absolute value of 7 equals 7 means that the number 7 is 7 units from 0 on the number line. And the absolute value of -7 is also a positive 7 because -7 is 7 units away from 0 on the number line. When you're evaluating expressions, the absolute value bars act as grouping symbols. So you need to evaluate or deal with the stuff that's between the bars first before you actually apply the absolute value to anything. Let's take a look at a couple examples. So evaluate 2.7 plus the absolute value of 6 minus 2x if x is equal to 4. First step is to plug in 4 for x. So I'll have 2.7 plus the absolute value of 6 minus 2 times 4. So I need to deal with the stuff between the bars first. So I need to turn 6 minus 2 times 4 into a number first. So I'm going to have the absolute value. Now apply order of operations to that. 6 minus 2 times 4, or 6 minus 8, the absolute value of that. Let's continue to evaluate between the bars. 6 minus 8 is -2. So now I have 2.7 plus the absolute value of -2. The absolute value of -2 is a positive 2, and that gives me a final answer of 4.7. So now to solve an absolute value equation, that is an equation that has absolute value bars in it, you have to realize that the stuff between the bars equals a positive number and a negative number. So if the absolute value of A equals B, then A is equal to B, or A can be equal to -B. Okay, here's an example with numbers. If the absolute value of x is 7, then x can be a positive 7, but x can also be a -7. So the stuff between the bars is either a positive number or a negative number. So let's take a look at several examples here. Solve each equation. I have the absolute value of x plus 5 equals 8. So that means that the value x plus 5 is equal to a positive 8, but x plus 5 can also be equal to a -8. So I need to write two equations. The way I remember it is I see two bars, two equations, I'm going to have two answers. So subtracting 5 from both sides, x is equal to 3. And subtracting 5 from both sides, x is equal to a -13. Now in the textbook, because there are two answers, they think of this as a set of solutions. So they put them in curly brackets. So this is set notation. It's not an ordered pair, these are curly brackets. This is just saying that there are two values that x can be. X can be a -13 and x can be a positive 3. Here's another example. -2 times the absolute value of 5x minus 1 is equal to -10. First thing I want to do is isolate the absolute value bars. So in other words, I'm going to divide both sides of this equation by a -2. That doesn't touch what's inside the bars, it just cancels out those -2's. So now I have the absolute value of 5x minus 1 is equal to 5. Actually, here's a hint. Make sure that your bars are bigger than your 1's so you don't mistake it for a 1. So this means I'm going to have two equations. 5x minus 1 is equal to a positive 5, and 5x minus 1 is equal to a -5. Now solve each one of those equations separately. Adding 1 to each side, 5x equals 6, or x equals 6 over 5. Adding 1 to both sides, x equals -4, or x equals -4/5. So I have two answers, -4/5 and 6/5. The order you put them in the curly brackets doesn't really matter, but I like to do them in numerical order, smallest first and then the largest. Okay, the absolute value of 3x plus 2 equals 0. Well, you're thinking 2 bars, 2 equations, but how do I deal with a positive 0 and a negative 0? 0 is just 0. Actually, we don't. This is the one case where you don't have 2 equations. It's just one equation. 3x plus 2 equals 0. Since I can't do a positive and a negative, 0 is just 0. 3x equals negative 2. X equals negative 2/3. So this is the one case where you're going to have only one answer. If the absolute value of an expression is equal to 0, you just have one solution. Number 4, the absolute value of x minus 3 plus 8 is equal to 3. Like 2 examples ago, I want to get the absolute value bars by themselves, so I'm going to subtract 8 on each side. So I have the absolute value of x minus 3 is equal to a negative 5. Well, let's think about that. So this stuff here, it's saying that whatever x is, subtract 3 from it, the distance between that and 0 is a negative 5 units on the number line. Well, we can't really measure distance in negative numbers. The other way, which you probably remember from middle school, is absolute value bars make something positive. So the absolute value of something can never equal a negative number. So the answer to this one is, looks like no solution, but technically we call that the empty set. There is no answer, okay? Because the absolute value of something can never equal a negative number. Okay, the absolute value of something cannot be equal to a negative number. So in this case, the answer is the empty set. Okay, the absolute value of x plus 8 is equal to 2x minus 3. This is going to be a little complicated because x plus 8 can equal a positive 2x minus 3 or the opposite of 2x minus 3, a negative 2x minus 3. Here's how we write it. My first equation is just without the bars, but my second equation, I need the negative of the whole expression, 2x minus 3. So I have to put parentheses around 2x minus 3 and have the negative out front. Okay, when I get to that one, I'll distribute the negative. But let's go ahead over here and solve. Let's see, so if I subtract x from both sides, I'll end up with an x over here. If I add 3 to both sides, I'll end up with an 11 over there. So x is equal to 11. So let's go ahead and do this one. X plus 8 is equal to distributing a negative 1, 2x plus 3. I'll add 2x to both sides, and I will subtract 8 on both sides. So x is equal to a negative 5/3. Now, here's one little thing you have to remember. I'm okay with the x equals 11. I'm pretty sure that's going to work. But anytime you have to do this, you need to check this side of the equation. So whenever you do this, whenever you have to make a whole algebraic expression negative, you must check. And I know checking is kind of a pain, and especially since we have a fraction, we have to do it though, because this answer may not work. Okay? So remember what checking is I take my solution and I plug it into the original equation. Is negative 5/3 plus 8, the absolute value of that, is that equal to 2 times negative 5/3 minus 3? So you can actually use your calculator to simplify this a little bit. You can do this addition here in your calculator, and it comes out to be the absolute value of 19 over 3. Is that equal to negative 10/3 minus 3? So is 19 over 3, because the absolute value of that would be positive, is that equal to, and doing this in your calculator, you end up with a negative 19/3. So no, it is not equal, so this solution doesn't check. but I'm pretty sure my 11 is going to be okay. So that is my final answer. So remember, anytime you have an algebraic expression on one side and you have to make the whole thing negative, distribute the negative, you must check that part of the answer. Okay, let's try another one that's similar to that. The absolute value of 6x plus 25 equals negative 3x minus 2. So let's go ahead and write our two equations. And 6x plus 25 equals the opposite of negative 3x minus 2. Okay, so this is going to give me a 9x, and subtracting 25 gives me a negative 27. So one of my answers is x is negative 3. On the other side, 6x plus 25 equals 3x plus 2, or 3x equals a negative 23. And again, we have another strange looking answer. X is equal to negative 23 over 3. And I have to check that one because I did this negative thing up here. So is the absolute value of 6 times negative 23 over 3 plus 25 equal to negative 3 times negative 23 over 3 minus 2. So what this turns out to be is the absolute value of negative 46 plus 25. Is that equal to, this ends up being 23 minus 2. So is the absolute value of negative 21 equal to 21? Yes, it is, because the absolute value of negative 21 is 21. So 21 equals 21. That does indeed check. So I have two solutions to this one. Negative 3, and here's where sometimes people get confused. They might want to put this 21 as the answer. This was actually my answer up here. Negative 23 over 3. Okay, and a lot of this here with the fractions can be done in your calculator, and we can go over that in class.